All right, so again, double click anywhere, and this is essentially the command line, but it's actually a little bit more intuitive than the command line in that it's more of a search. So if you kind of like mash in something, like there's no Grasshopper command, but it's going to try its best to think like, oh, did you mean diamond grid, but you're having a stroke? Like, here you go. So that's essentially how you search. So double click, right click to move around. Your middle mouse button also, that's how you zoom in and out. So you can just scroll in and out like that. So up at the top here, you're going to have different tabs. So I think you all should have up to the display tab, more or less. You can get more plugins for Grasshopper. So we'll be looking at Kangaroo, Weaverbird, and Lunchbox. So when you go through these tabs, essentially, they're all going to be grouped by their functionality. So the first one's going to be params. Anyone have a guess what param is short for? Yeah, that's it. So these ones, if you remember, we talked about parameters being the things in the building site, like in the Bjark Angles example, like the neighboring buildings, the flow of people around the building. So you can think of these as the inputs. So you can see here we have a few different things. We have geometry, and this will mostly refer to Rhino geometry. We have primitives. So these are things like booleans, integers, which are just whole numbers, floats, which are decimal place numbers, text, as well as some other things down here. Input, you have a lot of things, so you can see that Grasshopper can import shape files, you can work with gradients, color wheels, number sliders, panels. These two top ones will kind of be used all the time. Utilities, and some neat things in here. So Galapagos, maybe we'll get into that later on in the course. So math, the guy who wrote this, I think he's English or at least European, so he says maths instead of math. But essentially we have a bunch of domain components. So once you get out of the parameters, these are all the components, so things that act upon those parameters. So we have a bunch of domain functions. Matrix will never work with these. Linear algebra is the one class in my entire university career that I failed. So I never used the matrix operators because of that. Normal operators like that. So these are plus, minus, division, as well as some of our Boolean operators down here that we'll work with. So equals, larger than, similar to, smaller than, and, not, or XOR. Polynomials. So we're not going to be working with most of these, but all of you know basic math. They're there. Scripting, we won't be working with. Time, nope. Trigonometry, probably not. Utilities, maybe. So these are all related to math. Sets are going to be extremely important, and you will at first hate all of these, but then you'll love them. And because they're so most of the mistakes that people have in Grasshopper, I found, are just related to these in data management. So we're going to talk about that next class mostly. So yeah. So we'll work through all these. All of these essentially deal with the ways in which you organize data to make it work. So vectors, these are essentially directions and translations that can move geometry around, as well as planes. Curves, they're curves like you have in Rhino, and as well as some operations to transform those curves. Surfaces, we know surfaces in Rhino. So now we're getting into things that are a little bit more familiar. So all these tools work with surfaces. Mesh, we didn't really deal that much with meshes in Rhino 1, but we will deal with meshes a little bit in Grasshopper. Intersections, so that's like Boolean unions, Boolean difference, trim, split, like we have in Rhino. And then transformations, so these are our moves, our twists, our shear, our scale, array, things like that, as well as display. So these are if you want to, do mass amounts of dimensioning, or you want to make something a custom color. If you want to make a graph, you can make pie charts, bar graphs, quick graphs in Grasshopper. It looks way better than Excel if you ever have to make graphs, way faster than Illustrator. So those are all the things we more or less have there. As well, we have some commands down here. We have the sketch. If you ever want to remind yourself of something, you can do it like that. Again, one of these tools, I think that's the first time I've used it for a few years. You can also save your views like you do in Rhino right here, as well as, I guess this is view the entire document. Delete. To delete something, you just hit delete. So these are going to be our preview functions, but we won't really worry about those for now. Okay, so one thing to know, and when you save a Grasshopper file, so I'm just gonna so don't worry about what I'm doing, is we'll go through this after. Essentially, I'm just referencing. So I have a Rhino file that has a box in it. I have a Grasshopper file that is referencing that box. Essentially, when you save your file, you need to save them separately. So if you go to File, Save Document, you're going to notice that it's going to save as a Grasshopper binary. So you would save like box, and then you would also save your Rhino file. So this is just something to remember, and we'll go into this again, but saving your Grasshopper file does not mean your Rhino file is saved, and vice versa. So just to know. Also in File, we have New Document, Open Document, all the normal things. Preferences, which we won't really deal with. Later on, I'll show you how to load in a plugin, but we won't really deal with this stuff till then. And you have all your paste, view, and these things, I think it's kind of better to get to them as we need them. But for the most part, they're just like things you're used to. So like paste, arrange, bring to front, move backwards, move forwards. So if you're familiar with Illustrator, Photoshop, or even AutoCAD, you'll sort of get those. So I guess with that, we can actually get into what Grasshopper does. So first, what we'll do is we'll sort of look at an initial algorithm. So we'll sort of look at what goes into referencing geometry in Rhino. And then we'll look at doing a small example that's kind of like a little bit more practical, a spiral staircase. And then we'll do an example that's a little bit more fun sort of thing, box morph. So to start out with, even before we get into Rhino, we're just going to do something very basic. Grasshopper works linearly. So what I'm going to do, and if you guys want to follow along, I'm going to click on Input. So params, Input, Panel. This is going to act as our input. So we're going to double click to edit panel content. So and I'm going to type in 1. And then what we're going to do is, and we're not going to worry about this, this is just a demonstration of how this works. I'm going to right click it and go to multi-line data. So every component in Grasshopper, you can right click it to change some of its settings. So for panels, there's a little less settings, but other ones will have more settings. So to copy a component, so another thing to do, so you just click on it. So in this case, we're clicking on this panel here. And you can go, I just go Control C, Control V. You can also, oops, drag it down and hold Alt like that. So that's Control C, Control V, or start dragging it down and then hold Alt mid-drag. So now we have two of these. The nice thing about Grasshopper is, unlike Rhino, you can change everything. So in this case, we're going to click on this panel here. And now you can see that it opens up and it allows us to put in a different value. I'm going to put 2. So we have 1 and 2. So these we can think of as our inputs, or the parameters. There's 2 types of data in Grasshopper. So, and actually I'm going to use a number slider here. So what I'm going to do is I'm going to go to Parameters, Input, Number Slider. And I'm just going to put this down. Now you see it's a little slider which you can move back and forth. So there's 2 types of data in Grasshopper. There's what's called persistent data, so that's data that doesn't change. So in this case, it can be the 1 and the 2. Maybe it'll change, but for the most part right now, it's not changing. And then there's volatile data. So it can be this slider, and that can move up and back and forth and change the value. Volatile data will also refer to things that happen later on in your expression. But for the most part, you just need to know these are inputs. So to start working with this stuff, maybe I'll actually, well, let's keep those. Let's go to Math. And then under Operators, let's go to Addition. I bet you guys are on the edge of your seat. What's going to happen? 1 and 2. We're going to grab another panel. So we're going to go to Parameters, Input, Panel. So to connect things in Grasshopper, essentially there's a few ways to do it. So you can see in any component. So in this case, this is a basic component. It's addition A plus B. Every time you hover over a component, it's going to give you a description of what it is. So in this case, A plus B mathematical addition. Let's grab a random one. If we hover over this one, a viewer for data structures. So all of these are going to tell you what it does. Provides a list of preset values to choose from. So this can be handy to know what a component does. Likewise, if we right-click on this, it's going to have some more options. So preview, enabled, bake, variable parameters. The way you connect components is by hovering over the little node on the end of this component here and pulling it out. So you're going to see this little dashed arrow, and then you're going to plug it in. So you're going to see the dashed arrow will turn into a kind of ghosted gray line, and then you can just let go of that. So again, do the same thing with this. So now we have here 1 plus 2, because it's the addition component, and you can see the result. So result of the addition, you can see here it says 1 locally defined value, it's 3. We can also put it into this panel to give us our defined result. So 3. So, you know, that's maybe not the most exciting introduction to Grasshopper, but that's kind of how it works. It works in a linear way. You build up expressions like that. To unconnect panels, or components, there's a few things you can do. So anything you want to delete, you can just click delete. So if you want to delete this component here, you can highlight it, make sure it's selected, so it's going to turn green, and you're going to hit delete like that, and that'll just get rid of it. And now you can see that the panel we have here it's updated. So as soon as we deleted that, you can see it goes back to 1 because it's 1 plus 0, or empty. So we can plug in this slider here again. So now you can see what's happening is that as we move this slider around, the values are changing here. And this is what Grasshopper does to, constantly update. If you want to disconnect a component, you can hold Control and drag out from the component that you want to disconnect from. You have to go to the left. I guess you can go to the right. They've upgraded it. But essentially, what you can do is you just hold Control and you see this little red arrow there, and you can disconnect it like that. You can also, if you want to disconnect it, you can right-click. So you can right-click in different areas. You can right-click in the middle. That's going to give you your component preferences. And then you can right-click on the inputs themselves. So you can see here I'm right-clicking on the A, or I'm right-clicking on the B, or I can right-click on the R, and these give you the options for those inputs and outputs. So if you want to, you can also right-click on the B and then go to disconnect, that guy there, and that disconnects. Another thing you can do, if you want to add more than one wire into a component, you can hold Shift, so you see this little plus arrow, like so, and you can drag it, and now you can see that we have 2 values here. So we're putting 2 values into that second input. If you want to disconnect just this one here, you can do Control and drag up to it, and that'll disconnect it. So that's how you connect and disconnect components in Grasshopper. So does anyone have any questions about that? That's like as basic as you can get in Grasshopper. Okay. Oh yeah. If you want to do that, you can just go to Edit Delete. Yeah. I know that it kind of sucks, but maybe I'll look it up. There must be another way by now, but if not, Edit Delete works. So I guess another thing to point out, which is super useful, if you're like way out here and you don't know where any of your stuff is, essentially this little arrow here tells you which direction all of your components are in. So it's like you can see a little compass, which is nice. So why would you use this? Essentially, why don't we increase this number slider? So let's edit this slider. We're going to be using sliders a lot. If you double click on a slider, you can change the value in it. But again, if you right click it, go to edit. So everything to edit is properties. You right click. So right click it, go to edit. And essentially now you can see in the slider, it's going to give you some more properties that you can play around with. So in this case, it's going to ask you if you want to have floating point numbers, so decimals, whole integer numbers, evens or odds, as well as you can play around with its numeric domain, so the min number and the max number. In this case, let's set the max number to 100. Going to change that, so 0 to 100, and then I'm going to hit OK. So now you can see my numbers can go from, since it's 1 plus this, we can go from 1 to 101. So we have not really been playing around with geometry, but we will. So the thing about Grasshopper that's kind of maybe tricky as well at the beginning is that it works separately from Rhino. It references Rhino, but it doesn't work in Rhino. So what I mean by that is in Rhino, I'm just going to draw a box like that. You can draw whatever kind of box. And then So Grasshopper can't communicate with this box right now, and Rhino doesn't know Grasshopper is even open. It's just a separate program. To make them talk to each other, essentially what you need to do is you need to reference the geometry. So if you go to Parameters, first tab there, Geometry. In this case, so for most poly surfaces or extrusions, you're going to use brep. So brep is kind of one of the basic ones we'll use. So go to Parameters, Geometry, brep, plop it down there, and now you can see this is orange. We'll return to this, but essentially in Grasshopper there's going to be different kind of warning signals. So orange means it's a warning. It's like, so in this case, if we click on this little box here, so floating parameter brep failed to collect data, that just means this isn't getting anything. The other warning you don't want to see is you can get red warnings. So, and that means just like something's totally messed up. So let's see if we can make something go weird and mess up. Yeah. So if you see red, this means like something's totally gone wrong. So orange, not bad. Red, bad. So just a heads up. So right now this is orange because it's not referencing anything. To reference something in Grasshopper, you need to select in Rhino, right-click the component, and then go to, in this case, you can go set multiple breps or set one brep, so you can reference more than one thing. Of course, we're just going to go to set one brep. And you can see now that it turns red. Essentially what this means is Grasshopper's referencing it. If you click on this component here, the way that you know that this component right here is referencing this geometry is if you click on this component, it's going to turn green. That's essentially letting you know that it's selected. The other thing you can do to further, and this goes for any component, to further organize your thoughts, is you can right-click this component at the very top. So by default, it's going to be rep. You can give it a name, like Jerry or whatever. So that's how you can name that. So this is now referenced. So what that means, so I'm going to select the Grasshopper or the Rhino geometry, and you see I can still move the Rhino geometry around with the gumball like that. If I hide this Rhino geometry, so I'm going to hit Control H to hide it, you can see that all of a sudden I can't access in Rhino anymore. I can't move this thing around. And that's because only the Grasshopper geometry is there. And Grasshopper geometry can't be modified by Rhino commands. It can only be modified by Grasshopper commands. So, how do we use Grasshopper to modify this? Well, let's make use of this little 1+ sliding bar component we've set up. So we know that out of this component we get a value, so it's 1 plus whatever's there. It gives us a result of 101. Our very first thing we're going to do is we're going to just kind of play around with this. So the first thing we're going to do is we're going to perhaps move this cube up. So in this case, what we're going to do is we're going to go to vector, and then unit Z. So essentially what unit Z is it's telling Grasshopper the direction which I want to move this thing or perform another function in is this Z axis right here. So all of these vector components under vector, essentially are referring to directions. So in this case, you can see if we hover over unit Z like we do our other components, it says unit vector parallel to the world Z axis. We know that. If you look at F, it's unit multiplication. So in this case, you can see it has a default value there. One locally defined value is 1. We can take our result of the addition right here and plug it into our vector like so. So now we have, you can see, we have three numbers there, 0, 0, 101. Essentially what that means in this Cartesian coordinate system there is move 0 in the x direction, 0 in the y direction, and 101 in the z direction. So now that we have that direction, we can use another command in Grasshopper called move. So if you go down to your transform tab here, and then in Euclidean, we can just go to move. So if you look at move, oh, and also I didn't state, but to just move around components, you just click them, and then you can move them around on your canvas. So if we look at move, so again, transform, Euclidean, move. If you highlight over it, it says translate move an object along a vector. Components are always going to tell you what they need. So in this case, it says base geometry. Our geometry is going to be this box, so we can plug that box into move. And then translation vector. This is the vector we set up here. So we can plug that in. And now, what do you think we'll see on this screen right here? How many cubes do you think we'll see? Yeah, we're going to see 2 cubes. So does anyone have any idea why we see 2 cubes? So we can move this second cube around with the slider. Any idea why we see 2 cubes? Essentially, why we see 2 cubes is Grasshopper. The Mac version, for example, is called explicit history, which essentially means Grasshopper keeps track of every single step that leads up to the final step. And that's how it's able to maintain all the changes. So in this case, in order to have this second cube, it needs to continually reference that first cube. So how do you distinguish between the 2 cubes? One thing you can do is you can simply select the first one, and it'll be green, and you'll say like, oh, that's great, this one is green there. The second way is you can actually hide things in Grasshopper. So if you right click this first one here, we can now go to preview. So this little face here, click that, and then now you see it's turned off. So now we just have this second cube. Now this second cube, I'm going to unhide my Grasshopper object, or my Rhino object. So I just hit Control-Shift-H to unhide. What do you guys think will happen if I move this guy around in Rhino? What do you think will happen to the top cube here? Yeah, it's going to move with it. So even though it's not the reference geometry, so that original cube, since it is kind of tied up in that history, since it's based on this cube, which if we look at it, it's that reference cube there, it's going to move with it. So now everything's kind of linked up. Even if we wanted to, twist that cube in different directions, it's going to move with it. And it's always going to be 100 to 1 units higher than the other one. So that's like the very most basic. Now, I'm just going to preview these off. One thing to know is, like in Rhino, you can select things from the upper left and drag over them, or select from the bottom right to drag over them. Things turn green when they're selected. And when you select more things than once, you can click anywhere on the canvas, and then they're going to have different like group commands. So in this case, I'm just going to go to preview off. So one last thing before we take a little break. This second cube here is not in Rhino. But let's say we want to add it to our drawings, 3D print it, do whatever. To bring it back into Rhino, you have to bake it. So how you bake something is essentially you right-click on the component that gives you the iteration you want. So in this case, we wouldn't right-click on this original Jerry component here. we'd choose the move one. We'd see that the geometry that we want is highlighted, and then we'd right click it and then click bake with this little fried egg there. So essentially, if you have more than one layer, it's going to ask you, it's going to say what layer do you want to bake this onto. In this case, default's fine, so default's selected. I click OK, and now you can see that we have that Grasshopper objects turn into a Rhino object, and we can select it now and modify it in Rhino. Do you guys want to fathom a guess what's going to happen if I move this Rhino object up here? Yeah, exactly. Once you bake something, it takes it out of the Grasshopper loop. So these two are still connected, but anything that's baked is no longer connected to the rest of the objects there. So why don't we just take a quick break so I can get water and not die. Zoom. One thing about Grasshopper, and the reason why I really want to stress that parametric or algorithmic design thinking should exist separately from one certain program, is as soon as you get that mode of linear, step-by-step, logical thinking down, everything becomes a lot easier. So all these things seem really weird right now. As soon as we get over the basics, when it comes down to it, once you're at the point where you're like, okay, I know how to do something simple, then it's literally just about learning more commands. So it becomes a lot easier. So a big thing about Grasshopper is just gaining enough experience to know what commands to use. And that's why I say for your project, like, I'll sit down with you and like guide you through a lot of it, because we just can't expect you to know all these right away. So to kind of further demonstrate the fact that that kind of parametric design thinking can exist outside of Grasshopper, we're going to do first a little bit of parametric design in Rhino. One thing to know as well, if you close your Grasshopper window, so I'm going to hit close here, it doesn't delete your file if you didn't save it. It's probably a good habit to save, but if I open Grasshopper again like that, you can see it's still here, and it'll remain there until you finish your Rhino session. So one way to make something where you can modify things is to use something called record history. So in this case, what we're going to do is referring to, I don't know what this project is, but I just grabbed the image because it looks like, you know, kind of typically parametric. We'll sort of look at how to make a small skyscraper like this using Grasshopper eventually. But essentially, the way that you can do something like this, iterate through a bunch of shapes, is let's just draw a rectangle like so. And then what I'm going to do is with Gumball, I'm going to hold Alt, and I'm going to drag up two more rectangles like that. And now this is literally the only step. So we won't go into this much. You can explore this more by yourself. But we're going to hit record history before we do anything. So record history is on. And then we're going to go to surface, loft. And then we're going to select our curves to loft. And we're going to select them in the proper order, of course. So 1, 2, 3. Enter when done. Our direction looks fine. All these arrows look more or less aligned. And we're going to hit enter. We'll go to, let's say, a normal loft. That looks fine. I'm going to hit OK. You'll see that record history is no longer highlighted, but that's okay. Because now essentially what we can do is with these curves, we can move them and the loft will follow those curves. We can twist them and the loft is still going to follow those curves. So this is parametric in that there's parameters. They're the curves here. There's an algorithm. It's the loft. And we can change these parameters, but the command still stays the same. So loft is the algorithm. So this is kind of the first step of this. Now, what we're going to do is we're going to jump back in. So does anyone have any questions about that? Wants me to re-go through the steps? Okay. So essentially, we can go like that. So what we're going to do now is we're going to jump back into Grasshopper. Actually, first we'll start in Rhino. So to make something kind of like this, we are going to create a little, I don't know, pattern. So we're going to just grab another rectangle. So essentially what we're going to do is we're going to make a parametric facade. So I have this square here. I'm going to maybe draw some sort of wiggle in it. You guys can draw something else. I'm just going to mirror these. So they line up, but your pattern can be whatever. Essentially, we're just drawing a pattern in a square, so I have that. And then what I am going to do is I'm going to use trim, and I'm going to trim away the excess, like so. I'm going to join it, and then I'm going to extrude it. So I just have this extrusion there. If you're following along, you can do anything. You can do, you know, even a pyramid, whatever you want to do. You can make something weird. So what we're going to do is we're going to array this onto this shape in Grasshopper. So again, I can type Grasshopper, open it up. We're just going to move this thing to the side. One thing you can do in Grasshopper, if you want to group something, you can highlight a bunch of your components like this. You can right click outside of them and go to group. And now you can see this is a group that can move around. So we group that there just so we can maybe drag it out of the way down there. And that sort of, you know, it just keeps everything together. So we want to reference two things here. So if we go to parameters for this loft here, parameters, geometry, and then you guys remember which one we used last time? brep, yep. We're going to drop that down, and then we're going to right click it. So you can actually right click this before you select. Go to set one brep. Grasshopper is going to minimize, and you'll see it'll say brep to reference. So we can click that brep there, and now you can see we have our Grasshopper brep. So Grasshopper, if we move these around, you can see Grasshopper updates with our weird lofted rectangles. So that's great. I'm doing all sorts of weird intersections now. Okay, that looks better. And we also want to reference this. Maybe first we'll right click this brep just to name it, so we can say lofted shape. So we want to reference this extrusion as well. So now we're going to go to, well, we can just select that first. We can go to geometry, brep again, so we're referencing it. So right click, set one brep. I'll right click this, and I'll just name it, you know, tile shape, like so. So now this is essentially in these commands. So what we're going to do here, I go through this one first because it's kind of like one of the cooler but also easier things to do in Grasshopper. it's something that maybe you'd want to apply to your studio project right away. All of the commands in here, again, won't totally seem familiar, but you'll gain familiarity with them. So essentially what we are going to do, though, in here is we are going to break this down into surfaces. So just keep in mind, this is how you work in Grasshopper. It's shape by shape, or step by step by step. So maybe I can pose a question to you guys. If you were in Rhino to try to put these shapes on this shape in Rhino, what steps would you take? And you don't have to know the exact commands. Like if you as a person, let's say even outside of Rhino, wanted to by hand make a model with this shape on these sides, how would you approach it?
Divide that main volume by how many of those you wanted, and then just sort of break them on a scanner.
Yeah, that's actually exactly it. So that's the thing with Grasshopper, is most of the times it can do what you want, you just won't know the command. So in this case, that's exactly it. We divide it, and then we array these surfaces on the sides. So the first thing we want to do is divide up the sides. So we want to approach each side by itself. So in our lofted shape, here, we can go to our, so I'm just going to drag this out so we can see it, our surface tools. So surface refers to not only just surface geometry, but B-reps and everything. We can go to analysis, and then we can go to, so there's a bunch of ways we could do this, but we'll go to deconstruct B-rep. So you can see this flaming tin can. So that's surfaces, analysis, deconstruct B-rep. And you can see here it says deconstruct a B-rep into its constituent parts. So if we drop that down, highlight over B, it says base B-rep. We know that lofted shape is a B-rep, so if we plug it in there, that's good. You can see that some things have happened. We have some, I'm just going to preview off the lofted shape. So again, to preview off, you right-click a component, go to preview like that. Oops. So you can see in the B-rep, it's going to give us some different things. So faces of B-rep, edges of B-rep, and vertices of B-rep. And then you can see the value underneath here. So you can see here, whenever you go to Grasshopper and you hover over an input or an output, it's going to tell you what's in there. So in this case, it's 4 untrimmed surfaces. If you ever see, well, I guess it won't show it there. If you ever see something where you can't get all the data, like let's say there was 50 surfaces in here, so what it would do, and you'll see this eventually, is it'll say 50 locally defined values, and it'll say untrimmed surface, and it'll say ... untrimmed surface, like to be continued essentially. What you can do is you can go to parameters, panel. Panel is going to be super useful. Put down a panel, and then put your faces into the panel. So this just allows you to see exactly what's going on. So we'll get into this more next class, but all you need to know for now is everything in Grasshopper is numbered. So in this case, we have surfaces 0, 1, 2, 3. Numbering starts at 0. That's like a carryover from non-visual programming languages. So just remember, it starts at 0. Everything you're going to do starts with 0. So now with these faces, we have 4 of them. Essentially, like you were saying, we need to divide up these surfaces. So there's a few ways we can do this. Essentially, what we're going to do is we're going to go to Maths, Domain, and then we're going to go to, actually, we're going to go to divide domain squared. So you can see divide a 2-dimensional domain into equal segments. So now we're going to get some things. So again, that's math, domain, divide domain. This is going to be a very useful component. You can see the first thing here is base domain. we can actually plug our surfaces into that. So essentially base domain, if you guys, most of you are in, there's only a few faces I don't recognize. So we covered this in Rhino 1 very briefly, but I'll sort of restate it right now. Every surface, in the same manner that we have an X, Y, and Z grid in Rhino, every surface, and this comes into play a lot more in Grasshopper, has what's called a U and a V direction. So any surface can be thought of as a 2D surface, where this here, so let's say this surface here, let's show, well, even when it's highlighted, you can think of this one side here as having U0, U1. You can see there's another line here, U0, U1, U0, U1, and then V0, 1, 2. So it's like a grid on every surface. So essentially what we're doing here in divide domain is you can see the U count, number of segments in the U direction is 10. V count, number of segments in the V direction is also 10. We can change those numbers as well with, let's say, a slider, or we can just add them in, but for now we'll just leave them. Maybe we'll change them afterwards. So all this gives us is essentially, you can see here now, there's 100 of these shapes on each side of this object. And this is kind of a step-by-step where you more or less just remember, or need to remember, if I do box morph, that's what this is called. I just need to remember these steps. Again, I'll save this. So the next thing we need to do, now that our surface is divided, we can't see it, but we know it's divided, is to essentially make little boxes on the surface that fit into that domain. And those boxes are what you can think of as placing this geometry into. So to do that, we're going to go to transform, we're going to go to morph, and then we're going to go to surface box. So create a twisted box on a surface patch. So that's transform, morph, surface box. You can see here it asks for a few things. So base surface, our base surface is going to be these 4 faces. Let's see how this is. Okay, good. Our surface domain is going to be these segments here. Plug that in. Whoa. And now you can see something's going crazy. That's okay, though. We're going to get into this a lot next class. For now, just know that this works in this case. So right-click the S and go to Graft. And then, whoa, that looks great. So for now, if you want to so again, what we did there, if yours is looking crazy, like that, you notice this is like a teaser for next class. There's a dotted line. This line's solid. If we hit Graft, so I right-clicked on the S here, and then went to this thing that says Graft, all of a sudden everything's okay. So if you're really intrigued right now, you got to come to next class. So that's essentially all good. You can see here that these boxes actually have 3 dimensions. So they're sticking out. So essentially what we can do now is you can see the third input for the height of the surface box is height. So we've been working with putting in, for example, we put a slider into the input. So I just went to parameters input number slider there. So we've been working with putting in inputs like this, so you can see it maybe I'll increase this a little bit so we can see it more. You can see that as I increase this, those boxes here, they jump out further. Another way you can input values in Grasshopper, so I'm just going to delete this slider here, is you can actually right-click on the input. So you don't need to plug a component into it. So we can right click, and then you can see here it'll say set number or set multiple numbers. For this case, we just want one number. We can go over to this input menu, and we can input our numbers. So in this case, let's say 5. Make sure you click commit changes. If you hit enter, sometimes it exits. So to review that, right click on your input. In this case, it's the H for height. Set number 5. So let's go 6 and then commit changes. So that looks good. So
Mine is not. Okay.
Oh, weird. So yeah, this is a regular thing in this class where things will not work good. Okay, so and that looks good. Oh, actually, I know what this is. So your try scaling. Yeah, you need to select all of the objects that were there. So essentially what's going on is that, and I'll talk about this, is that, so where 6 works for me, since I'll refer to scale here for you, your objects seem a lot smaller, so probably what will work for you is like 0.1 or 0. So the problem that was happening there, and this is something to talk about, so I'm putting in 6. The units that my Rhino opens up to is millimeters by default. If my units were like one of the weird Rhino ones like angstroms or light years, this height would be 6 light years tall. But right now it's 6 millimeters tall. So that's something to watch out for. So what was happening was that if I decrease the size of this loft here, you can see, yeah, that's fine. You can see that it looks much different. And that's because the height is still 6. Whereas if we go out here, the height is still 6, but in relation to this object, it looks a lot more accurate. So that's something to keep in mind is units. So we have our boxes here. Now the last thing we need to do is essentially place this geometry in all these boxes. One nice thing to put, again, with Rhino, since we have recorded our history, if we move around any of these things, you can see that all of these boxes are moving with it still, which is really nice. And even if we, let's say, twist it, still our boxes are moving. So this is where you can start to see that Grasshopper starts to shine. It's like, okay, I need to show up to studio today with like 10 iterations of a design. I, you know, was an irresponsible person, haven't done that. Now you can quickly whip out 10 iterations like this. So we're going to select this. Well, we're not actually, but we're going to refer to this. So we're going to go back to our tile shape. And essentially what we need to do for this process is we need to put in a reference box and then translate it into these boxes. So to put this into a reference box, if you go to surface, and then these are one of these commands that honestly I always type it in. So okay, actually I found it. So it's surface primitive bounding box. Put that down. Again, if you want type commands, you double click, and then if you put, you know, bound, then bounding box is going to come up. So what a bounding box is solve oriented geometry bounding box. Essentially it puts a box around your geometry. So we don't have to worry about the plane here. So we can just put our geometry in there, and now you can see that we just have a box around this object. So we're going to use this to refer to the box to essentially map this geometry onto these surfaces. So to do that, I'm going to pull this up here. What we are going to do is we're going to go to transform, and then we're going to go to morph, and then we're going to go to box morph. So morph an object into a twisted box. So that's transform, morph, box morph. So now you can see again, like all these components, it has inputs and it tells you what it needs. So for G, it's base geometry. In that case, our base geometry is our shape here, because that's what we want to project onto all these surfaces. So shape, let's plug into G. R, it says reference box. So that's this little bounding box here that we just made. So you can see that the outputs here, there's two outputs here. So we have to look and see what one we want. So the first one is a line bounding box in world coordinates. And the next one is bounding box in orientation plane coordinates. We don't have to worry about that. When in doubt, usually choose the first output. So in this case, we want the first one in world coordinates. We'll place that here into R, reference box. And then T is the target box. Now, one of the nice things about Grasshopper is this here says target box singular, but in reality, we have 400 boxes. If we plug this into here, it's going to place in all the boxes. So let's plug the target box into here. Another thing to know about Grasshopper is sometimes if you're doing something big, you can see how my computer is kind of lagging. It's going to take a while. But if I'm going to hide our original geometry. If you ever have something like that where your Grasshopper screen just disappears when it's solving something, just type in Grasshopper and it'll come back up. I'm going to highlight all our components before this last one. I'm going to right click and then go preview off. Make sure that you don't go to disable. If you go disable, it'll actually turn off the components. So go to preview off, and then you can see in your perspective you have a really interesting pattern along all of your surfaces. So I'm going to hide these curves as well. Maybe let's look in Rhino. So does anyone have any questions about how we got to this point? Seems pretty good. So we can still make changes to this. So for example, all of our same curve tools work, or the translation. So if I decide to move this up, it'll take a second to update, of course, but you will see that our surface updates. So here we go. Here's our new, very structurally unfeasible tower. Also here, we have some other controls. So we could change our reference shape if we want to, or we could also change our height. We could also change the amount of U and V components. So let's say we felt that there were too many components in this direction. I think that's the U direction. Let's change it to, let's say, 5. And now you'll see it's going to update. And now we have less components in that direction. So now you can kind of play along with, or sorry, it was in the other direction. So you can play around with these. Like for instance, my middle part there seems really weird and twisted. Maybe it's the top too twisted. So I'm going to adjust that. Maybe make it worse. Maybe make it better. Okay, yeah. So we totally have a weird twist in our middle. But once you're done with all of this stuff, I'm going to hide this geometry here. I like hiding things a lot in Rhino when working with Grasshopper because it allows you to just sort of keep things in order. So I'm going to right click this, go to bake. Default's fine for me. And then it's going to create meshes. And there we go. If we drag this over, you can see that we have a Rhino object. So if you look at the rendered view, oops.
Are those all joined then, or can you move those in?
So these aren't joined, but that's a really good question. There's a few ways to talk or to approach it. So one thing you can do if you want to, let's say you want to keep them separate, you can, but you want to group them, you can go to transform, utilities, and then group. And then that way what's going to happen, plug that into group. Again, we'll cover this next class. I'm going to right click and click flatten. So now you can see the output there. It says group with 200 objects. So if you were to bake that, which I guess we'll do, then it will now be a group with 200 objects. So for something like this, and it's something I try to avoid, and if your computer is more powerful, you're going to run into this less often. So here's our group. So you can see here it is a group. So that's convenient. There are join commands, of course, as well. So in this case, just like we have Boolean union in Rhino, a lot of these commands are going to be very much like Rhino commands. Under surface, utilities, we're going to have brep join. So that's going to work kind of like a Boolean union. So if we plug this in here, because this wire was, oh, I guess it had a hard time joining these. That's okay. Sorry, there's also under intersection solid union, and that's actually what we want there. Sorry, I was mistaken. So join is like join in Rhino. It works for surfaces. Solid union, it works for breps. The unions and everything. So the reason why Grasshopper has its own tab dedicated to intersections is because they're like the most computationally intensive kind of command you can run. So you can see here, it actually didn't work for 2 of them. So unions start to get kind of weird in Grasshopper. I try to avoid them if you can, but they work a lot of the time. I think it didn't work in this case because we have like this bizarre twist in the middle where it's intersecting. So does anyone have any other questions about this process here?
Yeah, just thinking about something like, I don't know, one like a cube tower or whatever. Like, let's say, I mean, that's a pretty simple form. I mean, it's not parametric or anything. But let's say you had, you wanted to do something like that with different extrusions of those units, because each of these seem to be extruded or coming off the plane of that curve perpendicular to the curve. Is there any way to change it so it's coming out relative? So those are each extruded. Yeah, so
extruding straight out. Yeah, very much so. And we'll cover that more as we go into it. In that case, it wouldn't be box morph that you're looking for. So you're thinking of something actually more like this, where they're actually, yeah. So yeah, absolutely. Here, let's, okay, well, yeah, let's do that example. So I think what we're going to do is we're going to make another tower like this to sort of show how we can play around with things. So essentially what we're going to do is, okay, just give me one second to think, like, how do you do this? What's the easiest way? Okay, I got it, I think. One thing I will warn you, like, if you're like, oh, for my final project I want to do this, and it's like this or something, the amount of time I spend at your desk going like this will be determined by the complexity of what you ask me. So if you want to avoid like an awkward hour of me just sitting there and like looking off into the distance, keep it simple. Okay, so essentially what we're going to do is we are going to take a bunch of squares and we are going to, okay, actually no. We're going to start out in Rhino. So know when it's best to start out in Rhino. So if we're going to make a tower like this one up here, where there's different extrusions at different lengths, I'd actually kind of suggest that you start out with something a little bit more basic. So in this case, we're going to make a simplified version of that because we only have like 15 minutes. We are going to just draw in Rhino some of our base units, and then we're going to use these. So I just drew one square there. We're going to use these to kind of be our reference geometry, and we're going to scale them out from the center. So again, that's the thing with Grasshopper. It's like the reason why I was like just thinking about it even without looking at Grasshopper is that you always have to figure out how you tackle the problem, like regardless of the components in Grasshopper. So in this case, I was thinking, how do you make this? And I was thinking like, well, you can scale it from the center, but then you start to think about certain problems, like if you have a bunch of these, so I'm just going to copy these over like this. If you scale these from the center, so again, I'm just building up these sides here. If you scale transform mirror. Okay. So like let's say we have our center point, which is right here. In Rhino, like to you guys, do you see any problems if we say let's scale from the center? Like, do you see anything wrong for any of these given cubes? If we scale from this center point, do you think it's going to work? No, just for any. So if we want to essentially do this, so if we want to bring these cubes in and out like this, so only straight out like that, will it work if we scale from this center point? No, it won't, because if we scale from this center point here, so let's select this cube here, go transform scale 1D, scale from this point here to this point here, it's not going to work. And it's going to be even worse for this one. So scale from here, it's going to start skewing it. So those are the kind of things you need to think about in Grasshopper. Even before you know how you're going to do it, you just essentially need to think like, okay, I need to, figure out a way to do this. So I think perhaps one way that we can do this is we know that, let's say, we can, here, let's do this. So let's say one way we can do this is we can find the midpoint. So we can say, okay, for each of these cubes, we can find the midpoint on the inside. So, and then scale from there, because that's what we're doing. And if we scale from there, that seems to work for us, right? But now, again, it's like the question, okay, how do we find the midpoint in Grasshopper? So there's a bunch of things to do, but I'll sort of take you through how I do this in a, quick way. So I'm just going to rotate this around like that. So we get these. So this is something where I'll try to do it kind of quickly. We might not finish it. So I'm just going to preview this off. If you're working with different things, you can also right click and go disable. And now you can see how they're all gray and all the wires are orange. If you want to turn them on again, you can right click and hit enable. That turns them back on. But a lot of times it's good to hit disable. I'm going to go group as well, so right click group, because it's going to allow you to free up some memory. If these components are still doing something within Rhino, they're going to take up processing power, and which you'll learn out soon enough. Grasshopper can slow down pretty fast if you have too many things going on. Okay, so all these cubes, I'm going to select all of these. I'm going to go to parameters, geometry to reference, and then which one in here do you guys think we're going to use? Seeing as how these are curves, we're going to use curve. So we'll put this down right in the corner. Right click, this is one of those times where we're going to say set multiple, because we have more than one. So set multiple curves, like so. This might also be a time where, since we don't want to move around these curves like that, we might want to hide all of them just so we make sure we don't mess around with them in Rhino. So like that. And then what we need to do, we know we need to find the midpoint of the inside to scale, to have that as the point we want to scale from. We've already determined that. So can anyone here think about, so non-grasshopper terms, each of these squares has 4 sides. What is the defining feature of the inside side? And you can't say like it's inside. Like, what can you think of in Rhino here that differentiates those insides from all the other sides? What's it the best at? What's it the closest to? That's a big hint. Closest to. Exactly, the center. And that's what you need to think about in Grasshopper. It's not so much about learning commands, but just like logical thinking like that. So it's closest to the center. So essentially what we can do to grab that middle point, we can go, first we need to break up these curves into their edge components. So we're going to go into curve. We're going to go into analysis, or we're going to go into utilities and explode. So that's like the explode command in Rhino. So curve, utilities, explode. So curve to explode, we'll put in all these curves. So now you can see it gives us the vertices, so that's the corners, as well as if we look at the segments, they're right there. So now, essentially what we need to do is we need to test. So this is another thing that Rhino's good at. We need to test to see which one of these sides is closest to the center point here. The center point, first of all, we need that. So I'll show you how to enter in a point. If you want to reference 0, 0, 0, it's a good idea in Grasshopper to build around the origin just because it gives you like a good reference point. You go to parameters, geometry, point. So we can right click this point, go to set one point, and now you can actually type this in. So you can just go 0, 0, 0, like so, hit enter, and now you can see there's a point there. So you can do that for points. So now we have our 0, 0, 0 point. So now all we need to do is we need to say, okay, which curve is closest to this point? I'm going to preview that off. To do so, we're going to measure the distance between 2 points. So we're going to look for the midpoint of this surface, or this curve, because that's what we need to do to scale out anyways. So I'm going to go to curve, analysis, and then I'm going to go to point on curve. By default, it's at 0.5. We can move this around if we want, but we want it at 0.5 because that's the point we're going to scale from anyways. And then we're going to measure the distance between these 2 points. So we're going to go to vertices, or sorry, vectors, point, distance. Now you can see it says compute Euclidean distance between 2 point coordinates. That just means think of a tape measure between these 2 points. A is going to be the midpoints, and B is going to be that middle point. So now we have a bunch of distances. So we're definitely not going to finish this today, but is everyone following so far? We'll just sort of continue on with this next class.
I was going to ask if there's a way to set the midpoint if you did drawing
Oh, yeah, for sure. So if you want to reference a point, and this actually might be better, so in this case, you could reference a point, so we could literally go into Rhino, go single point, put that there, select that point, right click our point, and go set one point. Set one point. Oh, I guess they've upgraded that. And then, no, that won't follow around. But anyways, you could also well, anyways, yeah, I guess not, which is weird. But you can move things around as well. Like, I guess one way around this is you could always draw, if you wanted to move it around, you could always draw like a sphere, find the center point of that sphere, and then move that around. What you actually might end up doing, and maybe we'll add this on next class, it's probably too much to do right now, is find the point that's always in the middle of all this geometry. So even if you want to move around your overall geometry, you would always find the center point of that. But anyways, right now we have our distances. If we go to parameters input panel and look at the distances, plug in there, you can see all our distances. So you can see the closest ones. There's, you know, it varies, but always the smallest number is going to be that line. So maybe we'll actually leave it here. I know we haven't done much yet, but since we're going to be talking about sets and trees next class, the next step we need to get into sets. So I think that actually would be a really good place to start with that. So we'll continue this and then go into the next stuff. So are you guys right now in that phase where you're just like, it's starting to get this, but this is kind of weird, and what's this used for? And yeah. And that's the thing. It's like, as soon as you get this like logical step by step, and that's why I'm really trying to emphasize, like, it's literally just thinking steps. As soon as like you can get that kind of thinking happening intuitively, like Grasshopper just becomes a matter of learning what commands do what, like any other program. So perfect. Thanks, guys, and I'll see you on Wednesday. And also, if you want to play around with these, of course, they will be saved in the Grasshopper file. Also, email me, which is on the syllabus, if you have any questions between now and Wednesday.